Welcome to another deep dive.
Yeah.
This time we're going to be looking at this paper that kind of set the AI world on fire a few years back called Attention is All You Need.
Yeah, it was a big one for sure.
Huge. Um, Basically, it introduced this totally new architecture
Yeah,
called the transformer,
right.
and it's all about understanding these sequences, like words in a sentence or, even like stock prices over time, anything you can put in a sequence.
Exactly. Yeah, and the thing is, before transformers came along, we were stuck with these things called RNNs, recurrent neural networks.
Right.
And, they were fine for a while, but they were really slow, especially for long sequences.
Yeah.
It was like, imagine reading a book word by word. That's how an RNN worked.
Oh, so like one word at a time.
Yeah, one word at a time. And you can imagine if you have a really long book or whole library to get through.
Yeah, that would take forever.
It takes forever, and that's where this paper comes in with this idea of attention.
Yeah, like the transformer can speed read right instead
Yeah.
of going word by word.
That's a really good analogy. It can basically look at the whole sequence at once and figure out what's important.
So it's not just looking at each word, it's figuring out the connections between them. Right.
Exactly. It's all about relationships.
Okay, but how does that actually work? I'm trying to picture in my head, like if I'm translating a sentence, how does attention help the machine pick the right words in the right order?
So let's say you're translating "the cat sat on the mat" into French.
Okay.
When the transformer sees the word sat,
Right.
it doesn't just look at that word by itself. It uses attention to look at all the other words in the sentence,
Okay.
too,
At the same time.
at the same time. And it might pay more attention to words like cat and mat, because those are closely related to the action of sitting.
Oh, I see. So it's figuring out like which words are most important for understanding the meaning.
Yeah, it's about focusing on the most relevant information.
But doesn't that get confusing? I mean, if it's looking at everything at once, how does it know what order the words should go in?
Well, that's where this other really clever idea comes in. It's called positional encoding.
Yeah.
Basically, they give each word a kind of position tag so the model knows where it is in the sentence.
Okay. So it's like giving each word a little address.
Exactly, like a little GPS tag so it knows where it belongs.
Got it. So it can look at everything in parallel, which makes it fast, but it doesn't lose track of the word order.
Exactly, that's the genius of it.
And that's pretty cool.
Yeah.
Now, the paper also mentioned something called multi-head attention. It's not like a bunch of transformers working together?
It's more like having different teams within the transformer, each looking at a different aspect of the sentence.
Oh, I see.
You could have one team that's focused on the grammar, another one that's looking at the meaning,
Right.
maybe another one that's figuring out the emotional tone.
So it's like different perspectives.
Exactly. And by combining all those different perspectives,
Yeah.
it gets a much richer understanding of what's going on.
That sounds incredibly powerful, like so many levels of analysis happening at once.
It is powerful, but it's not perfect, of course.
Oh, right. Nothing's perfect.
There are still things that transformers can struggle with, like really complex or nuanced language.
Yeah, that makes sense.
And they need a lot of data and computing power to train.
Right.
But, research is ongoing, and it's really exciting to see what people are coming up with.
I can imagine it's like this whole new frontier of AI.
It really is. And it's amazing to think that it all started with this one paper, "Attention is All You Need."
It really did change the game. And I remember they threw it at some really tough translation tasks.
Yeah.
And it just blew the competition out of the water.
Oh, yeah. It achieved a BLEU score of 28.4 on the WMT 2014 English to German translation task.
Wow, that sounds impressive.
That basically means it was way more accurate than any other model at the time.
So it was more accurate and it was faster too, right?
Much faster. Remember how those old RNNs were so slow?
Yeah.
Well, the transformer could be trained much faster, which is a huge advantage.
Okay, my mind is officially blown. But I do want to get into some of the nitty-gritty details.
Oh, yeah.
Like they talked about tweaking the architecture and the training process, all that good stuff.
Yeah, they really went deep on how to optimize the transformer for best performance, and there's a lot to unpack there.
Let's do it. Okay, so let's talk about those experiments they did, tweaking the architecture.
Yeah, they were basically trying to find the best configuration for the transformer. One thing they played around with was the number of attention heads.
Oh, right.
Yeah.
Those different teams we talked about, like one for grammar, one for meaning.
Exactly. And what they found was that having multiple heads was really important.
Okay.
But if you had too many heads, it could actually hurt performance.
Well, that's interesting, like too many cooks in the kitchen.
Yeah, exactly.
Yeah.
It's all about finding that sweet spot, the right number of heads for the task.
So what else did they experiment with?
They also looked at the size of those keys. Those things that help the model figure out which parts of the sequence are most important.
Right.
And they found that bigger keys led to better understanding.
Which makes sense. I guess like the more information you have, the better you can connect the dots.
Exactly. But all this talk about attention heads and keys makes me wonder, like, how does the transformer actually learn all this stuff?
Yeah, it's not like someone's sitting there programming in all the rules of grammar and meaning, right?
Right, that's where training comes in.
Yeah.
And it's a whole different ballgame compared to those old RNNs.
Oh, yeah. How so?
Well, remember how we said RNNs were like reading a book word by word?
Uh-huh.
Training a transformer is more like giving it a whole library to devour.
Wow. So it's like learning by immersion.
Exactly. You
Yeah.
feed it massive amounts of data, millions of sentences, all carefully labeled and translated.
Okay, and I'm guessing you need some serious computing power to handle all that.
Oh, yeah. For this paper, they used 8 NVIDIA P100 GPUs.
8 GPUs. That's insane.
It was top of the line back then, but even with all that data and computing power, there's still the problem of overfitting.
Right? Where the model just memorizes the data instead of actually learning the patterns.
Exactly, and that's where those clever techniques like dropout come in.
Oh, right. You might hear that.
It's like randomly covering up parts of the text during training.
Okay, so the model has to fill in the blanks.
Exactly. It forces it to think for itself and generalize from the patterns it sees.
That's really clever. So what about those amazing results they got? Did the transformer live up to the hype?
Oh, it totally did. It smashed all the previous records on those benchmark translation tasks.
Like what kind of scores are we talking about?
Well, on English to German, it got a BLEU score of 28.4.
Okay, and remind me what that means.
It means it was way more accurate than any other model at the time, including those complex ensembles.
Wow, so it was like a solo artist beating out a whole orchestra.
Yeah, it was a huge deal. And not just for accuracy, it was also way faster to train.
Right, because those RNNs were so slow.
Exactly. The transformer could be trained much faster, which is a huge advantage when you're dealing with these massive data sets.
Okay, I think I'm starting to see why this paper was such a game changer.
It really was. And the impact goes way beyond just translation. They also tried it on this task called English constituency parsing.
Which is?
It's basically figuring out the grammatical structure of a sentence.
Okay, this is like identifying the subject, the verb, all that stuff.
Exactly. And even without any special modifications, the transformer did a really good job at this task.
Wow, so it's not just a one-trick pony?
Nope. It's a multi-talented model, and it shows the power of this attention mechanism for all sorts of language tasks.
This is incredible. So we talked about the results. Now, what about those visualizations you mentioned?
Oh, yeah, those are really cool. We can actually see how the transformer is understanding language.
Wait, really? Like we can peek inside its brain?
Kinda. The authors of the paper included these diagrams that show the attention patterns of the model.
Okay, let's take a look. Okay,
Yeah.
so let's see these attention visualizations.
Yeah.
I'm super curious to see how the transformer is actually connecting the dots.
Yeah, it's pretty mind-blowing. One of the things they showed was how the transformer can handle these long-distance dependencies in a sentence.
Oh, you mean like when a phrase is spread out over several words?
Exactly, like the cat who was sitting on the mat suddenly jumped up.
Like the subject cat and the verb jumped are pretty far apart.
Yeah, and the visualizations showed how the transformer was able to link those words even though they were separated by all that other stuff.
So it's like the model understood the whole phrase as a single unit, not just a bunch of individual words.
Exactly, it's about seeing the bigger picture.
That's amazing. What else did they show?
Well, they also showed how the transformer could figure out what pronouns refer to. You know, how pronouns can be tricky.
Oh, yeah, like he or she. It all depends on the context.
Right, like the dog chased the ball and then he wagged his tail.
We know he refers to the dog, but a machine might get confused.
Yeah, but the transformer didn't. The visualizations showed that it correctly linked the pronoun back to the right noun.
So it's not just matching words. It's understanding the relationships between them, who did what to whom.
Exactly. It's a much deeper level of understanding.
It's starting to sound a lot like real intelligence.
It really is, and it gets even cooler. Some of the visualizations showed that different attention heads were specializing in different tasks.
Oh, really? Like a division of labor.
Exactly. One head might be focusing on the grammar, while another is trying to figure out the meaning.
So it's like a whole team of linguistic experts all working together.
Yeah, it's an amazing example of teamwork.
No wonder this transformer thing is so powerful. So we talked about the research, but what about the real world? How is this actually impacting our lives?
Well, it's already having a huge impact. Think about those large language models you hear about, like ChatGPT and BERT.
Oh, yeah, those things are everywhere right now.
Well, those are powered by transformers.
Really? So the things that can write poems and have conversations and answer my questions about quantum physics, those were all built on this transformer architecture.
That's right. And it goes beyond that. Transformers are being used in everything from speech recognition to machine translation to image captioning.
Wow, it's everywhere.
They're even being used in fields like finance and healthcare to analyze complex data and make predictions.
It sounds like the transformer is becoming the Swiss Army knife of AI.
It really is, and the applications are just going to keep growing as people find new ways to use it.
This whole deep dive has been incredible. We've gone from the nitty-gritty details of attention to the mind-blowing implications of the transformer, and it's clear that this is just the beginning.
Yeah, it's an exciting time to be following this field. The transformer represents a fundamental shift in how we approach AI, and who knows what amazing things we'll be able to do with this technology in the future.
It's inspiring to think about. So to our listeners out there, if you're curious about the future of AI, pay attention to the transformer. It's a game changer. Thanks for joining us on this deep dive.